All right, so Foundations of Math 10, 2.5. Let's take a look at this section here. We'll do just kind of a quick intro. There's not a whole lot to learn other than applications of the trig functions that we've been learning. So take a moment to, I want you to try and figure this problem out right here. It's a survey poll. So now what they're trying to do is they're trying to find out the distance between this transit and the survey pole. Now a transit is sort of something, you see these on the roads. They set up a little tripod and they kind of look through. It's kind of like a telescope almost, and it has like marks on it and stuff. And they look through, and at far away down the street, they have someone with a pole. And in order to get long stretches of roads nice and flat, what they do is they kind of use these transits, and they try and figure out how high or low the road needs to be way down over there. So they kind of look and make sure that it's centered up, and then they know they have to go, down or up or whatever to make it a little more level, or to see what the incline is. So we've got a pond, and we've got a transit right here, and there's a survey stake right here and a survey pole over here. Okay, so they're going to try and make sure that maybe they're doing a bridge or something, or maybe I don't know what they're doing, but they want to make sure that whatever they build over here and whatever they build over here is at the same level. Okay, and they can't walk through the pond and do all that sort of stuff, so this is how they do it. So 1 minute with a partner. How could you determine the distance between the transit, that's this right here, this point right here, and the survey pole? And take a look at this diagram, and how would you figure that out, and try and figure out an answer to that. Go, you've got 1 minute. Okay, hopefully you've had a little bit of time to think about that here now. So I want you to notice a few things, okay? So we do have a right triangle, right? That is important. A right triangle, check. We do have an angle given, okay? An angle is given, check. And we do have one side given, check. So that means that we could use SOHCAHTOA to solve this. So how many of you used sine maybe to solve this? Anybody? Anybody use tangent to solve this? Anybody use cosine? Okay, I see hands going up. Okay, well, let's see. According to this angle right here, or related to this angle, we have the adjacent side given. And we're trying to find the angle that's opposite the 90, the hypotenuse, right? So adjacent and hypotenuse, that's going to involve the cosine. So good job, use the cosine. So we're going to set this up as cosine of 46.5 equals adjacent side divided by hypotenuse. So let's make this x here, okay? This is the unknown side x. And in order to solve for x, we multiply both sides by x, so this x comes up here, and I divide both sides by cos of 46.5. So we're going to be left with this. The x and the cos of 46.5 really just switch positions, and this is what you're going to be doing on your calculator. Okay, so I'll get my calculator going here. And turn it on, clear it up. Okay, so 110 divided by cos 46.5. And I think I'm in degrees. So, am I in degrees? Okay, did anybody get 159.8 meters? All right, I think that should be correct. So x equals 159.8 meters. Now, does that seem reasonable? Yeah, it's bigger than 110, for sure. Yeah, if it was like 40, if you got 40, you're like, 40? The hypotenuse is always the longest side in a right triangle. So if you got 40 on your calculator, you know that something's wrong, right? And you go back and you check what you did. Excellent. Okay, so we're just basically applying sine, cos, tan, we've already done it. This is mostly sine and cos. So using sine and cos to calculate lengths. So let's do this one as well. This is an example in your textbook here. Determine the length of BC. And so BC is this length right here. It's also little a, right? That would also be little a if you'd like to use little a instead. To the nearest tenth of a centimeter. Okay? So is it a right triangle? Yes, it is. Do we have an angle given? Yes, we do. Do we have at least one side given? Yes, we do. So we can solve for the third side or another side of the triangle really easily now by using one of the trig ratios. We have to figure out which one we're going to use. So according to this angle, or related to this angle, we have the hypotenuse given, and I'm trying to find the adjacent side. Good. This would be the opposite, and this is adjacent. So what involves hypotenuse and adjacent? Yeah, it's cosine again. Nice. So cosine of the angle 50 equals the adjacent side, 5.2, divided by, adjacent side, A, divided by the hypotenuse, 5.2. So this one becomes really easy because A is already in the numerator, so all we have to do is multiply both sides by 5.2, and we get A by itself. Awesome. One quick step. So what's 5.2 times cos of 50 degrees? 3.34. 3.34. Now, does that seem reasonable according to this question? Well, that's 5.2, so 3.34. This is going to be a longer side than this for sure, so yeah, it seems pretty reasonable, right? And that should be your answer there. Any questions? All right. Remember, always start with the formula, fill your values in, isolate the variable. Let's do another one. Here's an example, again, another transit survey pole situation. We're trying to, how could the surveyor determine the distance from the transit to the survey pole? So that is this distance here, from the transit to the survey pole. Now you can't probably see that. So what part of the triangle is this that we're trying to find? Hypotenuse. Very good. So we're trying to find the hypotenuse. What are we given according to the angle that we're given here? Adjacent. Yeah, we're given adjacent. Oh, wow. Cosine again. Look at that. So cos of 67.3 equals adjacent side, 20.86, divided by the hypotenuse. Okay. I'll just make that hype. So again, these proportions are really easy. You're going to multiply both sides by hypotenuse, divide both sides by cos 67.3. Or in reality, the shortcut is these two can switch places. If one's on the bottom on one side of the equation, one's on the top on the other side of the equation, then they can always just switch places. So hypotenuse is equal to 20.86 divided by cos of 67.3. Or the distance is, anybody get an answer there? 54.05. Okay, nearest hundredth, so 54.05. Distance 54.05 meters. I like it. Okay, so shortened lesson, shortened class. It's just applications of cos and sine. So we didn't do any sine questions, but again, if you're given the opposite side length and try to find the hypotenuse, use the sine. All right. Take care. I'll give you some time. Tomorrow we'll complete this.